Hello, my name is Roland Texan with Game of Apps, preparing youth for 21st century careers. Today we're going to be talking about hex numbers or hexadecimal numbers and RGB values. So let's jump right into it. First, we're going to talk about counting. Now, I know a lot of you have probably learned how to count even before grade 1, probably even before kindergarten. But today we're just going to look at how we count, and we're going to dive in deeper to understand a bit better what actually happens when we count. So here we have the numbers 0 to 11 and ... So we all know how to count. But let's see. From 0 to 9, we actually have just one digit representing the numbers. And then when we get to 10, we have two digits representing the number. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, those symbols represent a number using one digit. And then when we get to 10, we need two digits to represent the number. Let's see what actually happens there. So here I've broken it up into two columns. The right column shows you the first digit. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, we know what that means. And then 10 takes two digits. And then 11 is also two digits. And I think most of you understand implicitly that 11 is 1 10 plus 1, right? So 20 would be 2 10s. So let's jump into that even further. So here what we're saying with 0 is we have 0 10s and then 1 1 and 0 1, right? 0 1s and 0 10s and 0 1s. That gives us 0. The number 1 is 0 10s and 1 1, which is 1. And so forth until we get to 10. So 1 0 means we have 1 10 and 0 1s, which gives us 10. All right, so we're breaking it down, but that's actually how we count and how we represent numbers. This representation of numbers is called base 10. There's other ways to represent numbers. So this representation of numbers is called base 10 because there are 10 digits. 10 digits in base 10. And then when we go past the 10th digit, in this case 9, then we need two digits to represent a number. Hexadecimal is a different way of representing numbers. It's done using base 16. So that means there's 16 single-digit numbers in base 16, or in hexadecimal. So let's take a look at that. If we're going to count in hexadecimal, or base 16, we'll start with 0, 1, 2, 3, all the way up to 9, and then we need 6 more single-digit symbols before we get to 1 0. Okay. Now, we don't have those symbols in our numerical representation. So what mathematicians and computer scientists do is they represent that with the letters A, B, C, D, E, and F. So from 0 to 9, those digits represent the numbers 0 to 0, 1 to 1, all the way to 9. The digit 9 represents the number 9. And then now we have a digit A, which represents the number 10, the digit B, which represents the number 11, the digit C, which represents the number 12, the symbol or digit D, which represents the number 13, the symbol E, which represents the number 14, and the symbol F, which represents the number 15. And then at that point, we've hit 16 symbols. So in hexadecimal, now we need to flip over to two digits. Now we have the number 10, and the number 10 in hexadecimal represents the number 16. Okay, let's take a look at it this way. So previously I showed you these columns here in base 10. Now let's do this in base 16. So a single digit 0 means we have 0 16s and 1 1. So, 0 1. So that gives us the number 0. And then the digits 0 1 would give us 0 16ths and 1 1. So that gives us 1. And so forth until we get to 9. 9 means it's 0 16ths and 9 ones, which gives us 9. Now we get to A. So what is A here? Well, if we look at what we said earlier, A is 10. So A means it's 0 16ths and 10 ones, which gives us the number 10. And B represents the number 11. B is the symbol for 11. So we have 0 16ths and 11 ones. The same with C, D, E until we get to F. F means there's 0 16ths and 15 ones, which gives us the number 15. Now we get to 1 0. Now we would like to call this 10 usually, right? Because that's how 10, but in base 16 we can't call that 10 because the number 10 means 10, like 10 items. So here we would say this is 1 0. So in hexadecimal, the number 1 0, what does that represent? As we said earlier, the number 1 0 means that we've rolled over. Now we have 1 16 and 0 ones. So 1 16 and 0 ones gives us the value 16. So the number 10 in hexadecimal gives us the value 16. And so forth. Now 1 1 gives us the value 17. And all the way down 1 7, it's 1 16ths and 7 ones, which gives us the value 23. Okay? So some of you I might get this right away. Some of you might need to think about this a little bit more because we're not used to counting 16ths. You know, we're used to counting base 10s. And I think the reason why we count in base 10s is because we have 10 fingers, right? Imagine if we had 16 fingers, then hexadecimal would probably be natural to us. Okay, let's take a little quiz just to test our understanding. So here we have the number 20. What does that mean? Well, 20, that means in the 16th place we have 2. So we have 2 16ths. And in the ones place we have 0. So what does that give us? 2 16ths is 32. 32 plus 0 is 32. So that's the number 32. Okay, 3C. What is 3C? 3C. Well, 3 is 3 16ths. So we've got 3 16ths. And C, what is C? Well, we know that A is 10. So A is 10, B is 11, and C is 12. So 3 times 16 plus 12. What's that? Well, let's bring up our calculator. Okay, 3 times 16 plus 12 equals 60. So this gives us 60. Now, some calculators automatically gives you base 16s. Here we have base 10 and base 16. There's also a different way of representing numbers called base 8, which is octal, but we're not going to cover that today. So let's switch to base 16 to see if this gives us the same value. 3C. So that's right. Tells us that 3C here is, in base 16, is the number 60 in base 10. Let's do one more. Let's do 3D. 3D is, well, actually, I don't need to calculate this. Because if I know that 3C is 60, then 3D is 1 more than 60, right? So 3D is 1 more than 60, so 3 16ths, and D is 1 higher than C, which is 13. So then this should be 61, right? Now let's look at the next number, A0. A0, that means there's A16s. Okay, I'm just going to write this down to show you. A16s and 0 1s. A16s. What is A? A was 10, right? So A equals 10. So that means there's 10 16ths and 0 1s. So 10 16ths is 160 plus 0 is 160. Okay, let's see if that's correct. Okay, let's go here. A0, and then if we switch that to base 10, that's 160, which is what we got. Okay, last one. C times CB. Okay, so that's C 16ths and B 1s. Okay, what is C again? C we said was 12. And B we said was 11. So that's 12 16ths and 11 1s. So let's calculate that down. We're in base 10. So 12 times 16 plus 11. Okay, so that's 203. Okay, let's confirm that. So base 10, 233. Let's switch to base 16, CB. Okay, so I just walk you through some calculations on how to convert between hexadecimal and decimal. Now here, let's see what this is. 2A0C. What do you think this is? Let's break this down. So C was ones, and then the second digit here are 16ths. What's the third digit? Well, in base 10, we go from ones to tens, and then hundreds. Hundreds is 10 times 10. So in here, following the same pattern, it would be 1 16ths and then 16 times 16. What's 16 times 16? Well, let's bring back our calculator. 16 times 16. Okay, so this is 256s. Okay, and then how about the next space? In base 10, it would be 1, 10, 100, 1,000. What's 1,000? 1,000 is 10 times 10 times 10. So in this case, we want 16 times 16, which is 256, times 16. So this next space here would be 4,096s. Okay, makes sense so far, right? So what do we have here? We have 2 times 4,096 plus A times 256 plus 0 times 16 plus C times 1. Okay, let's do these calculations. What's 2 times 4,096? Well, I have it here. 2 times 4,096 equals 8,192. Okay, what's A times 256? Well, we said A was 10, right? So 10 times 256 is easy, 2560. 0 times 16 is 0. And C times 1, what's C? Well, A is 10, B is 11, C is 12. So that's 12. So let's add that all up. We have 8192 plus 2560 plus 12 equals 10,764. 10,764. So that's what we've calculated 2A0C in hexadecimal is. Let's double check in our calculator. Let's switch to base 16 and 2A0C. That's right. Okay. So those are examples of how we do the calculations. We'll do one more, a little bit easier, but this one is a special one. FF. Okay, what is FF? Let's do our calculations again. The first digit of F is ones, and the second digit is 16ths. Okay? And what is F? F is 15. The symbol F represents 15, right? A is 10, B is 11, C is 12, D is 13, E is 14, and F is 15. Okay, so we have F times 16 plus f times 1. So that's 15 times 16 plus 15 times 1. Okay, what's that? Let's calculate. Let's go back to base 10. So 15 times 16 equals 240 plus 15 times 1 is 15. We add that up, what it is, that comes up to 255. Okay, let's do a check here. Base 10, 240, we're going to switch that to base 16. Oh, sorry. We said 255. 255, base 16 is FF. Okay, this is a special number, which we will talk about in the next little bit. Okay, so RGB, computers represent colors using a mixture of three components, or three component colors, red, green, and blue. Hence we get this abbreviation RGB. So here I just ran the color meter, and you can see this this orange color that we use in our logo Game of Apps. It has the RGB value of 242 for R, 139 for G, and 88 for B. So this is the computer representation of this particular orange color. R is 242, or red is 242, G or green is 139, and B or blue is 88. So what does that mean? So in the computer, we represent values, the red, green, and blue values, on a scale from 0 to 255. 255 is the maximum value, and 0 is the minimum value. Remember I showed you the hexadecimal FF earlier? And that value is 255. So that's why it's a special number, because it represents exactly 255. So, another way to represent this in hexadecimal is the minimum value is 00, and the maximum value is FF. And we have minimum and maximum values for all red, green, and blue. They each have their own values. And combine that, we get our specific color. So here, for example, we have a color picker. This happens to be the color picker from Adobe Photoshop. And you can see here that if you pick a color here, that's exactly the orange that we have for Game of Apps. Then the RGB values would be 242, 139, and 88. And here it also tells us the hex value. The hex value is F28B58. Okay, that's the hex value. So that's exactly this here. F28B58. The first two digits is the red value. The second two digits is the green value. And the last two digits is the blue value. So F2 represents 242 in decimal. 8B represents 139. And 58 represents 88. So that's how we represent RGB values, both in hexadecimal and in decimal. So now the question is how to distinguish hexadecimal from decimal values. For example, if you saw this number F28B58, is that decimal or hexadecimal? Yeah, it's hexadecimal. Why? Because decimal numbers do not contain the symbols F and B. So this is pretty obvious, right? Because we see the symbols F and B here, this must be a hexadecimal number. Or it can't be a decimal number. Now what if we had a number that looks like this? 188758. Is that a decimal number or a hexadecimal number? We don't know. We can't tell. Just by looking at that, we can't tell. Right? It could be either 188,758. That's if it was a decimal number. Or if it was a hexadecimal number, it would be 1,607,512. That's a huge difference. So it's very important for us to know whether this is a hexadecimal or a decimal number. So what mathematicians and computer scientists do is that we have a special symbol to represent that this is a hexadecimal number. We use that's called an octothorpe. So that octothorpe, or a hashtag, which we call nowadays, but that represents a hexadecimal number. So whenever you see a number that starts with a hashtag or starts with an octothorpe, then we know that that's a hexadecimal number. Okay, the last thing we're going to talk about today is how Android represents colors. So we talked about the RGB values. There's one more value, which is the alpha, or A. And the alpha is basically the transparency. How transparent is this color? So in the same way the RGB goes from 0 to FF, the alpha value also goes from 00 to FF. So FF being completely opaque, so it's completely non-transparent, and 00 is completely transparent, or in this case it would be invisible. And anything in between would be various grades of transparency. So basically the alpha value corresponds to the transparency of the color, how much you can see through this color. So for example, here, this would be an 8-digit hexadecimal number. We would have FF, F2, 8B, and 58. So the first pair, FF, would be the alpha value. In this case, the value is 255, so it's completely non-transparent. And then the second pair would be the red value, the third pair would be the green value, and the fourth pair would be the blue value. So this is how we would represent the complete RGB plus alpha, or RGBA value in Android. There is a shorthand because most of the colors that we represent would be completely non-transparent. So if you only did 6 digits, so you can skip out the first 2 digits, and if you do that, then Android will automatically assume that your alpha value is FF, or 255. So if you skip the first pair of numbers, then you would be just specifying RGB. So if you provided 6 digits, if you provided 8 digits, then the first 2 digits would be the alpha value. So today we talked about a few things. We talked about hexadecimal, how to count in hexadecimal, how to convert between hexadecimal and decimal, hexadecimal being base 16 and decimal being base 10. Then we talked about RGB values, how the computer represents any color that it can display using RGB values, and the red, green, and blue values would have value between 0, the minimum, and 255, or FF, which is the maximum. Then we also talked about further representation of colors using RGBA, A being the alpha, or the transparency level. And then lastly, we showed you how we would represent RGB or RGBA in Android. Great, so that's it for today. Have a good day and talk to you soon. Bye-bye.